All right, so we're going to look at two more ways to show that triangles are similar. The first one is the side equals side similarity theorem, which is Theorem 7.1. What Theorem 7.1 says is if an angle of one triangle is congruent to an angle of another triangle, and the sides including those angles are in proportion, then the triangles are similar. And I'm going to restate it in maybe an easier way to think about. If two sides of one triangle are in proportion with two sides of another triangle, and the included angle is congruent, then the triangles are similar. So what we are going to have are two triangles, and because I have this nice little clone property, I'm going to use it. So we have triangles ABC and triangles DEF. And we are given that we have two sides of one triangle in proportion with two sides of another, which would be AB is to DE as AC is to DF. And the included angle, so what we have is, and these aren't congruent, so allow me to just kind of put a squiggle there. Those two sides correspond and are in proportion. And these two sides correspond and are in proportion. They're not congruent, no. It's just they form a proportion. If you go single squiggle to single squiggle, it will equal double squiggle to double squiggle. Okay? Now it's not even really the way anyone else does it. It's just something for me so I can visualize it. So I can help you visualize it. Okay? Bar and Tommy, I want you guys to stop talking to each other. So we know that, and then we know that the included angles are congruent. Well, the included angle will be the angle between those two sides. So angle A and angle D are going to be the included angles. Now what we want to prove is that this would mean that triangle ABC is similar to triangle DEF. Actually, angle A is congruent to angle D. Might be what you're having on the time. Now, what we are going to do is we're going to locate a point X on DE, so that the length of dx is equal to the length of AB. So we're going to locate a point x on DE so that, in fact, AB and DX are congruent. Then we're going to draw a line through X that's parallel to segment EF. And we'll call the point where that line crosses DF, we'll call that point Y. Now what we do know is that triangle DXY is similar to triangle DEF. Why are triangles DXY and DEF similar here? Because they share angle D. What else? When the lines are parallel, we have congruent angles, don't we? So corresponding angles are congruent, which means by angle, these triangles are similar. Let's go ahead and start writing out this proof. To start writing the proof, we need to tell everyone how we located point X and how we drew XY. So, actually we located point X so that dx was equal to AB. Next, we drew line XY parallel to EF. So triangle DXY is similar to triangle DEF. Because corresponding angles of parallel lines are congruent. I'll say by postulate 15 first, or by angle-angle similarity postulate. Because corresponding angles of parallel lines are congruent. I'll mark this other angle as well. Now, by the definition of similar triangles, I am going to be able to come up with not only AB equal to DX, but some of the other sides have to be equal because of this proportion. So since triangles are similar, I'll use blue again. I can say DX is to DE as dy is to df. By definition, similar triangles. Since AB equals dx, and since AB to DE equals AC to DF, I can say by substitution and by transitive property that AB will be to DE as DX is to DE as DY is to DF D Branson and Dustin as AC is to DF. Part of this was given, AB to DE equals AC to DF. Part of it is substitution, because AB to DE equals, or sorry, AB equals DX. So AB to DE will equal DX to DE. Part of it's transitive property then. So dy to df equals AC to df. From these last two pieces here, you can conclude that dy equals AC. And I'll say by substitution and transitive property. Now, if we look at our diagram and what we know about this diagram, I'll shrink this down so we can look at our diagram. Still didn't get AC to DF. There, I'm getting it. Let me look at what I have. We now have not only is AB equal to DX, but AC is congruent to DY, which means that triangle ABC is congruent to triangle DXY. And that would be by side equals side. So since ABC is similar to since DXY is similar to DEF, and since ABC is congruent to DXY, I can do a substitution there and say triangle ABC must be similar to triangle DEF. The next theorem we're going to look at is Theorem 7.2, which is the side-side-side similarity theorem. And what it says is, if all three pairs of sides of both triangles are in proportion, then the triangles are similar. So, Theorem 7.2, side-side-side similarity theorem. If all three sides of one triangle are in proportion with all three sides of another triangle, then the two triangles are similar. Dustin. Good. Yes. Then pay attention at least. So again, we're going to have two triangles. What we're going to know about these two triangles is that their sides are in proportion. So triangle ABC, triangle DEF. And this proof follows the other one. We're still going to locate a point x. So starting by locating a point x on DE so that dx is equal to AB. And then drawing a line through x parallel to EF and calling the point where it intersects DF y. So in our proof, we can start out with, we know that AB is congruent to dx. We'll locate point x on DE. So that dx equals AB. And draw xy parallel to EF. Starts out the same way. As before, triangle DXY is similar to triangle DEF. Which means all their corresponding sides are proportional. So dx is to DE as dy is to EF. Dy is to DF as xy is to EF. By definition of similar triangles. Now, since AB equals dx, I can do the same thing as I did before. Since AB equals dx, then I can make a substitution. I know that AB will be to DE as dx is to DE, and I know that then it's equal to each of these other pieces in the given. It's equal to AC to DF and BC to EF. So if I arrange it nicely, since they're all equal, I can use that transitive property. It doesn't matter what order I have them stated. I can state AC to DF next, and dy to DF next, and BC to EF next, and finally xy to EF. And if I take them two at a time, this middle piece will help me know that AC equals dy, and the right-hand piece will help me know that BC equals xy. So this happens by the substitution in transitive property. I'm going to shrink all of this so I can look at what we have now. So if we have AC equal to dy and BC equal to xy, then we have congruent triangles. And again, because these two triangles are congruent, and since dxy is similar to def, ABC will have to be similar to def. So triangle ABC is similar to DEF by a substitution of congruence. It will be time to go when the bell rings because we have late lunch, which means you have 5 more minutes, which means you are interrupting class, which means you are getting the sizzling fingers.
Where's your throat stuff? Why don't you